Day 263 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem. This time we're at day 263 of doing daily LeetCode problems. And today we have question number 23, merge case sorted list. The difficulty level is hard, but don't worry because we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, check out that link in the description. Now let's see what the question says. Question says you are given an array of k-linked list. Each linked list is sorted in ascending order. Merge all of the linked list into one sorted linked list and return it. All right, so it sounds simple enough, but let's look at example one just in case so we can know exactly what it is that they want us to do. So in example one, we have the input list equals an array of linked lists. Those linked lists are 1, 4, and 5, 1, 3, and 4, and 2 and 6. Right? The output is a linked list 1, 1, 2, 3, 4, 4, 5, and 6. The explanation says the linked lists are, right? We have 1, 4, and 5, which is this linked list right here. We have 1, 3, and 4, which is this linked list right here. And then we have 2 and 6, which is this linked list right here. So the input, they give us an array of linked lists, and we have to merge all of those linked lists into one linked list and return it into ascending order, right? So it says right here, merging them into one sorted linked list, we get a 1 from right here, this linked list right here, boom. Then we have another one right here, which comes from this linked list right here. Then we have a 2, which comes from over here. Then we have a 3, which comes from right here. We have 2 4s, which come from right here and right here. Then we have a 5, which is right here, and we have a 6, which is right here. And this is just an example of this right here. It's the same numbers. So as you can see, all of these integers right here are all included in these 3 linked lists that they give us in the input. We just have to merge these 3 linked lists and then also sort them in ascending order, meaning from smallest to greatest. As you can see, these numbers go from smallest to greatest, which is ascending order. So let's look at example 2 and example 3 for real in case they try to throw some some tricks our way. So in example 2, we have the input list is just a blank array and we return a blank array. Boom. In example 3, it's a blank 2D array, or it's a blank array with a blank linked list, and we just still return a blank array. So as you can see, this is 2 arrays. This is an array inside of another array, but we still just return a single blank array. So we just need to remember that when we're creating our output. So now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution's not that difficult, and we should get through it fairly easy. So let's get started. First thing we need to do is we need to initialize an array which will store the values of all the nodes in the input linked list. So in order to do that, we're just going to declare a variable. We can call that R. We can say colon. Then we're going to open up the square brackets. We're going to say int. We're going to put int inside of those square brackets. Then we're going to say equals a blank array, right? So we're just going to initialize it with a blank array. Now we need to iterate through all of the non-nil linked lists in the input array. Now, remember, so this might be an example of a nil linked list, right? Imagine if this was over here. We need to iterate through just the non-nil linked list. We don't need to iterate through any of these. We just need to iterate through the non-nil linked list. So in order to do that, what we're going to do is we're going to say for list in list dot compact map. Compact map. We're going to open up the parentheses. Then we're going to open up the brackets and we're going to put a $0 inside. Now, this $0 represents each one of these arrays, right? Or each one of these linked lists in the initial array. So this $0 represents all of these linked lists separately, though. So each one of these is its own linked list. This $0 represents all of them, which are inside the initial input array. So now we're going to come outside of those parentheses and we're going to open up our brackets. We need a pointer to traverse the current linked list. So in order to do that, we're going to declare a variable. call it head. Then we'll say colon. It's going to be a list node. Then we're going to say question mark equals list. Boom. And now we're going to say while head exclamation point equals nil, which means this exclamation point equals means while head does not equal nil. That's what this exclamation point means. It does not equal nil. If it's 2 equals, it'd be equal to, but exclamation point equal means does not equal. So while head does not equal nil, we're going to open up the brackets, and we need to append the value of the current node to the array. So in order to do that, we're just going to say r.append, open up the parentheses, and we're going to say head exclamation point dot val. And now we need to move to the next node in the list. So in order to do that, we're just going to say head equals head dot next. Boom. Just like that. Now we need to sort the array to ensure all node values are in ascending order. So in order to sort it, we're going to come outside of this for loop. We're going to say r.sort with the parentheses. Now make sure you say sort, not sorted. It's not dot sorted. That's going to give you the wrong answer. You say r.sort, just sort. And now we're going to come down here and we're going to say if the array is empty, we need to return nil because that means there are no nodes to merge. So now we're going to handle the case if this is empty, right? Or like this, one of these. So we're going to say if r dot is empty, boom, we're going to open up the brackets and we could just say return nil, just like that. Boom. Now, we're not done yet. We need to create a dummy node to simplify building the new merge link list. So in order to do that, we could just say let node equal list node, open up the parentheses, and put a 0 in between those parentheses. Now we need to initialize the first node with the first value in the sorted list or in the sorted array. So we're going to say declare variable. We're going to say cur equals, so we'll say var cur, excuse me y'all, var cur for current, short for current. We're going to say list node, open up the parentheses, open up the square brackets, or not yet, we'll say r, open up the parentheses, then we say r, open up the square brackets, 0, just like that. And now we need to link the dummy node to the first node. So in order to do that, we can just say node.next equals cur. Boom. Now we need to iterate through the sorted array starting from the second element, because remember that first element is going to be our dummy node. So in order to do that, we're going to say for n r dot drop first. So remember, we're dropping that first dummy node, open up the brackets. We are going to say let tmp equal list node, open up the parentheses, n. And that is going to create a new node for each value in the array. Now we need to link the current node to the newly created node. So in order to do that, we're going to say cur.next equals tmp. Boom. Now we need to move the pointer to the next node, so we could just say if let next equals cur.next, open up the brackets, we say cur equals next. Boom. Now, last but certainly not least, we need to return the merge linked list, which is going to start from the first real node, or meaning, when I say real node, meaning we're going to skip the dummy node. So in order to do that, we could just say return node dot next, because remember that first node will be a dummy node. Now, that should be all she wrote, y'all. Let's run it. Hopefully it works. Okay, we got an error. Let's see. We'll say value type list node. Got a typo. Should be compact, not compact. Throw that C in there. Compact. Let's see. Okay, now this is an optional, so we need to put a question mark after head. Let's run it again. Let's see. And it's accepted, y'all. So let's submit it. Make sure it stays accepted after we submit it. because you never know with this LeetCode stuff. It'll get accepted, but not when you submit it. And look at that, y'all. It works. 5 milliseconds beats 87.73% of users with Swift. Not too bad, not too bad at all. Those numbers are all right. Could be better, but they're pretty good. So before we leave, make sure y'all get one more look at the code, y'all. One more look at it. Read it, learn it, love it, internalize it. Do whatever you have to do in order to make sure you learn from this video and you're able to apply this knowledge that you learned in future LeetCode problems. And now, with all that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.